architecture GPUs. And again, number one is very close to home. The Tsubame KFC supercomputer, which is at Tokyo Institute of Technology. I just found out yesterday that KFC stands for Kepler Fluid Cooling, not the Kentucky deep fried chicken that you might associate with KFC. But the name is appropriate because it is the processors are immersed in oil to manage the thermal cooling for the computer. So the processors run at a very reasonable, lower temperature than in an air-cooled or water-cooled system, and so you get more power efficiency. I think it's a really great machine, and maybe the way to the future for supercomputing. We may see a lot more oil-cooled systems. So the other implication of Kepler, besides moving up the computing food chain into supercomputing, Kepler has also moved down into our mobile architecture. You may or may not know, historically, our mobile architecture, the Tegra family of processors, had a different graphics pipeline used for desktop and computing and laptop. The progression of architectures for the desktop, from Tesla to Fermi to Kepler and on to Maxwell, are fully capable, fully functional, does all graphics, does all computational graphics, supports CUDA. With the introduction of our Tegra K1 mobile processor, we've now unified our architecture. So going forward, we'll be building a single graphics architecture which spans the full gamut from mobile and embedded architecture all the way up to HPC. And what that really means is that all the capabilities from programmable graphics, visual computing, all the way up to CUDA and programmable parallel computing are available from embedded architectures to be deployed and developed all the way up to very high end. So now I'd like to demonstrate the truly awesome power of Tegra K1. If we can switch to the demo. Amazing quality of graphics for a mobile device. Let's take a little drive through here, explore the environment, see the nice quality reflections of the water, the damp floor. You see the indirect lighting and special effects, the God rays in the background, the light shining through the atmosphere. So really, this is virtually indistinguishable from the desktop gaming experience. Truly capable, and this is all running on Tegra K1 development platform, running under Android. Pull up the Android menu here. As you can see, it's fully integrated with Android. So it's very exciting. Thank you very much. Let's go back to the slides. Okay, so Tegra K1 allows a whole bunch of new experiences for handheld and embedded devices. Besides gaming, which I've just shown you, the recent Google I/O conference, I showed you the gaming, which is part of the new gaming environment on Android. We're also very involved with Android TV, computer vision on a tablet. The Tango project, we capture 3D information with a tablet. We're in Chromebooks. We're the first Android Auto platform, and we're also the first development platform for 64-bit ARM with Android, the Android L release. So we're really enabling the great breadth of GPU computing on Android everywhere in Google I/O. So it's a truly impressive platform, and we built a truly amazing development vehicle for it. Jetson TK1 is what we call the first mobile supercomputer for embedded systems. We have Tegra K1 on it, and all the other peripheral connectors, memory, and all the other pieces so that you have a fully functional computer on a board. So it's a mobile supercomputer. This has 192 CUDA cores. CUDA 6.5 offers support for ARM and development, a bunch of tools, SDKs, and libraries that allow you to develop applications on this platform. And this is 326 gigaflops on a very small mobile chip. It's really a tremendous achievement. And you can get hands-on experience with this here today, and it's also available in retail. You can order one. I don't know the Japanese price, but it's very cost-effective, very excellent entry into GPU computing and development. Okay. So one other more about is machine learning. And machine learning is a pretty old branch of artificial intelligence, first explored maybe 50 years ago. And the idea is that computers can, on their own, learn from data, from information that you present to them. And the best way to be able to do this is unsupervised learning, where the computer program will go through a whole sequence of training data, for example, images, and figure out what can be recognized. Just like humans, we're born without the ability to identify and recognize specific kinds of objects or animals, but we learn over time as we experience our life. You want to have a computer program that's doing machine learning be trained on a set of images and learn to recognize a person or a dog or a cat very effectively. This is very hard to do, though. So this is, we're at a very special time in the history of machine learning because there are a few trends that are converging, things that are happening at the same time. The first one is there's an explosion of data. I mentioned that earlier. Just a few years ago, there were approximately 300 million images being uploaded to the internet every day. And today, probably by the end of this year, there'll be close to 2 billion images uploaded per day to the internet. And all of this is just people's pictures, and they're unclassified. You don't know what's in those pictures because you would like to be able to figure out, recognize faces, recognize people, like recognize objects. We'll show you a bunch of pictures of cats, for example. There's also a study in deep neural networks, which is a approach for machine learning, and the growth of GPU computing, the explosion of parallel pervasive computing. The three of these things together are enabling a real explosion in machine learning. So a while back, Google, in Google Labs, built a project called Google Brain out of 1,000 CPU servers, over 16,000 cores, spent quite a bit of money and quite a bit of power, over $5 million, to build a deep learning system that they were able to train over the course of many weeks to recognize a variety of features and images. So there's considerable excitement about just scaling up to this level of being able to do that. Sometime later, Stanford AI Lab was able to duplicate the performance in terms of recognition quality of Google Brain with a much smaller substrate. So 3 GPU accelerated servers, roughly the same number of cores, installed GPUs, and about 1/150th of the power and much lower cost. So we really see machine learning becoming pervasive, getting much more broadly applicable. And another example of this is ImageNet, which is a very large collection of images that are commonly used as a baseline for machine learning training. There's a challenge that happens every year where people write their own programs to compete with other people who are trying to demonstrate that they can recognize features in image. And just last year, more than half of the teams competing in this effort were using GPUs. So you can really see that this leverage, this advantage of highly parallel computing is something you can't ignore. It's going to revolutionize machine learning. So you can see this by the fact that many large companies are using machine learning for production for real products. There's a lot of important research going on in universities in this area, so the field is moving very, very rapidly. There's a very broad collection of use cases. I just mentioned the image classification, but pretty much any situation where you have a large volume of complex data and you want to extract some meaning from it, machine learning is going to be the way to proceed. It's the only way we can deal with that scale of data. So I think this is a very exciting development. Next, I'd like to have some presentation about enterprise virtualization, and I will step off the stage. And please welcome Mr. Mark Hamilton, who will talk about this topic. Welcome, everyone. It really is amazing that we've come this far, as the words in the opening video said. If you think about it, it was only 21 years ago that NVIDIA was founded, in 1993. It put the first GPU in a PC on the desktop. And think back to 1993. There's been a lot of change since then. Unless you worked at CERN Labs in Switzerland, you probably had no idea what the World Wide Web was. And unless you lived in Finland and worked for Nokia, you were still, if you had a cell phone at all, it was an analog cell phone that only did voice. And of course, you had a GPU on the desktop. And David spoke about all the great things that have happened in graphics and in computation. So let's talk a little bit about the changes going on in enterprise virtualization. Enterprise virtualization 2.0, as we call it. Surprisingly, with all those changes in the last 21 years, enterprise virtualization is really focused on the server and has left behind graphics on the desktop. I'm not sure if anyone has ever used VDI, but because traditional enterprise virtualization did not use a GPU, it was not a very good experience. And it wasn't until recently, until all of the great engineers at NVIDIA started to work on our virtual GPU technology, they were really able to make a difference. And for the first time in 21 years, that GPU on the And what you would expect the performance on the right, on the low-end laptop, when you virtualize in the data center using all these software-based graphics, you get the very poor experience on the left. Again, users, and I'm happy with this, did not install NVIDIA Virtual GPU in great technology, was adopted by Citrix, were able to deliver a real graphics performance in a VDI of a virtual enterprise experience. So, a short video is nice. You can actually see that video on YouTube. But if you follow me on Twitter, I did one this morning and I'll take a photo of this. So we wanted to make sure that all of you when you left could not just see us video, we wanted to record it on time. And I expect some of you, they want to talk to Citrix, your hardware OEM, and actually start a trial in your own company of graphics accelerated VDI. We wanted to make it even easier. Right now, so please welcome Mr. Masaki Sawai, who's going to come up and give a demo of the Great Test Run.
それでは実際にブリッドテストライブ見ていきたいと思います。ブリッドテストライブっていうのはまさに通常のパソコンと皆さん使いのパソコンとインターネット回線その2つです。ブリッドテストライブを使うのはNVIDIA の次をちょっと持ちいきます。初代ブリッドテストライブを使いますとブリッドテストライブのプレイステーションにつながります。こちらでテストドライブを試してくださいボタンをクリックしていただくとアカウントの登録画面に移ります。こちらでご登録をお願いします。登録は無料となっております。登録が完了しますとブリッドワークスペースというソフトウェアをダウンロードするとなります。ダウンロードして PC にインストールします。以上でブリッドテストドライブを使う準備が完了します。それで実際にブリッドワークスペースを起動しています。まずはですね、ログイン情報を求められます。こちらはですね、登録で使用した情報を入れてください。私のメールアドレスと設定したパスワードですね。そして、接続先なんですけども、こちらアジアを選んでいただくと、日本の皆様、快適にお伝えいただきます。そして、サインインのボタンを押しますと、パブリッククラウド上で仮想マシンが立ち上がり、デスクトップの準備が始まります。宿泊すると、このように、Windows の画面が出てきますが、こちらがですね、クラウド上で動く Windows のデスクトップでございます。こちらのデスクトップはですね、NVIDIA グリッドによって GPU アクセラレーション、両立完了となっております。そして、このブリッドテストドライブでは、デスクトップ上にですね、あらかじめデモ用のアイコンをしております。ダブルクリックしていただければ手軽にご覧いただけますので、アプリで。Thank you. つまりは PC とインターネット環境だけがあれば、いつでもどこでもですね、ブラックスを使った仮想デスクトップ体験可能となります。登録は無料となっておりますし、今現在からお使いいただけますので、ぜひ皆様、そっちのお試しください。と気に入っていただけると思います。ありがとうございます。Thank you.
Thank you. That was an amazing demo. And once again, it wasn't just a demo running on the laptop here or in a server behind the wall. That was, for the first time in 21 years, the full power of NVIDIA visual computing technology brought to you from a server in the cloud here in Japan, delivered to your desktop. And all of you can go, maybe not all at the same time, but go and sign up today. Less than 2 minutes to sign up. You can get your own graphics accelerated session. And if your company or your university or organization decides they want to do an on-site trial, we have all of our partners in the room here today. Citrix, VMware, Cisco, HP, IBM, we're here to help you do that. We can not only bring you more GPU, of NVIDIA technology. So in the short period of time, we showed you how we've taken the GPU off of the desktop for graphics, finally enabled enterprises, and in fact, the cloud service providers to bring that back into the data center. But that's not the only place we're taking GPUs. You saw how the Honda car was designed on the outside and inside using GPUs. Virtually every single car on the market today
lot of advanced technology.